Good morning, everyone. Thank you for the time and the opportunity. I would like to thank the Honorable Reviewer team, the Honorable Committee of the Conference, and also the Honorable Audiences. May we always be given a very well health in the midst of this global pandemic. I would like to say welcome. My name is Boby Rusdyanto, mechanical engineering student of Universitas 11 Maret. My research is about tensile strength assessment of recycled polypropylene filament or RPP as 3D printing material. This research is based on associative problem that we have not been able to escape from plastic consumption until this day. We can no longer tolerate the plastic waste. If we allow it, it will be back and attack us. Then become a very worrying problem for a human being. The data shows that domestic waste is dominated by plastic, especially in packaging form. An example in our daily life is plastic packaging. The conclusions that can be drawn from the data give us a statement that the plastic packaging is dominated by polypropylene or PP type plastic, which is one of thermoplastics kind. Let me make it clear. So, thermoplastic is a kind of plastic that can be softened again, then could be built into other useful goods. I try to hook up between PP plastic with 3D printing technique, which is a thermoplastic processing technique by utilizing its ability to be softened back into other useful goods. Therefore, plastic waste has a potential to be reused. In addition, this is a way to reduce the amount of plastic products that directly dumped, but to be reused during their lifetime. This potential raises new questions. What about the quality of the plastic waste? If it used with 3D printing techniques, can polypropylene or PP plastic waste be better or at least comparable to standard PP plastic? In this study, I choose to focus on processing of recycled PP or RPP filaments in 3D printing techniques and choose the industrial standard polypropylene or PP and polylactic acid or PLA filaments as benchmarks by setting the 3D printer's nozzle temperature as the dependent variable, and I set the temperature variations to 180, 190, 200, 210, and 212 Celsius. In this study, the data collection generally consists of three processes. Sequentially, there are the extrusion process, 3D printing, and tensile testing. In this study, post-consumer plastic packaging used is Indomie instant noodle packaging plastic, produced by PT Indofood CBP Sukses Makmur. The plastic packaging was initially chopped using a paper shredder into small pieces. After that, the extrusion process can be carried out. The extrusion has used an extruder machine. The machine owned by Laboratory of Vibration and Machine Maintenance, Faculty of Engineering UNS. The machine is a single screw type and the rotational speed is 24 rpm. There are two heating systems applied to the barrel and nozzle. They are set at 185 Celsius. The nozzle diameter used is 1 mm. The extrusion process produces filaments. They called as recycled polypropylene or RPP filaments. Then the filaments are processed in 3D printing. The 3D printer machine used is the Creality Ender 3 with several modifications. There were the replacement of the main drive into a direct drive, and the use of a chamber to maintain the ambient temperature around the machine. The last was a clear insulating tape on the bed for the printing process of RPP and PP filaments. The 3D printing process is carried out to build the dog bone samples for tensile testing. Sample preparation were made with nozzle temperature variations at 180, 190, 200, 210, and 212 Celsius, as well as several parameter settings that I list in the display. Besides that, dog bone samples from industrial standard PP and PLA filaments were also prepared as benchmarks. The dimensions of the dog bone samples were made according to the Type 5 ASTM D63814 standard, and there were prepared as much as 3 pieces for each variant. The tensile test has used the Universal Testing Machine or UTM owned by Laboratory of MIPA Terpadu, Faculty of Mathematics and Sciences, UNS. The test used a load cell capacity of 5,000 kg force and a testing speed of 10 mm per minute. The data then collected in a crate. The data shows that the highest ultimate strength value is at 210 Celsius. When the temperature reaches at 180 Celsius until 210 Celsius, it appears that the tensile value increases with the addition of the nozzle temperature, then decreases when it reaches at 212 Celsius. Based on this phenomenon, we can conclude a hypothesis that the operating temperature of the RPP filament is at 210 Celsius. The data of Young's modulus almost shows a similarity with the ultimate tensile strength data. The highest modulus value is at 210 Celsius. These results support the hypothesis that the operating temperature of the RPP filament is at 210 Celsius. However, anomaly appears in data trend of temperature range at 180 Celsius until 210 Celsius. The modulus value appears to decrease at 190 Celsius and increase again at 200 Celsius, then reaches a peak at 210 Celsius. Finally, decreases again at 212 Celsius. The down value at 190 Celsius was thought to be due to the presence of voids, thus affecting the interior of the dog bone samples. The presence of voids plays a major role in reducing the density of the samples. The more voids will affect the lower of sample strength. For the last, we can conclude that the highest tensile properties were found at 210 Celsius for RPP filaments. Besides that, the RPP filament has a potency to replace the industrial standard PP filament, as long as consider the limitations in the printing process. In terms of the tensile properties obtained, I think it's all for my research explanation. Thank you for the opportunity and attention. Good morning.